Okay, good afternoon all. Okay, and now in today's session, we are going to discuss the design of the plastic part. And in this design of the plastic parts, we are going to discuss the how the ribs are designed. Okay, how the ribs are designed, how the bosses are designed, and how the gussets are designed. Then how we are going to give the coring. Okay, and how we are going to provide the radius and fillets. Okay, in this we will discuss one by one. We will start with the ribs. Okay, now whenever we are providing any kind of the part or then first we should understand what is the necessity of that particular design. Okay, whenever we are designing any kind of the plastic part, suppose here we are going to discuss the necessity to provide the ribs. Then what will happen if ribs is not there, or why we are providing the ribs? Which kind of means additional properties it will provide in that design? Okay, or how it is going to add a value to our design? That we have to discuss. Initially we have to discuss that, and after that we have to provide the some design related guidelines. Okay, guidelines related to the design of the ribs in the plastic parts. Okay, in this way each part we will discuss. Okay, ribs, then bosses, gussets, scoring, radius and fillets. We will first we will start with the this ribs. Okay, and then first I will show you practically what is the ribs. Okay, I have added one diagram. Okay, this is the diagram. In this diagram you can see clearly in the suppose this is the okay, this is one view of the plastic part. Now in this this around cylindrical portion, hollow cylindrical portion you are seeing able to see here, this is the boss. Then the horizontal plate like structure which is connecting the rib, that boss to the wall surface, this is the connecting rib, or simply you can say that the ribs. Okay, these are rectangular in shape, and similar structure, but it is in triangular in shape. It is termed as the gusset. Okay, this is the gusset. Then this is the rib, and this is the boss. Okay, and here we have provided some holes, and this is the radius inside and outside. Okay, inside radius and outside radius, or you can say it as a fillet. Okay, you can say this part as a fillet. This is outside radius, this is the fillet. Then we are going to discuss related to the what is the purpose behind providing these extra, you can say that, extensions or protrusions. Okay, one by one we will see. So I will repeat it again. This part is the ribs. This cylindrical, hollow cylindrical portion, it will be termed as a boss. And this triangular supporting portion is termed as the gusset. And these are the radius or fillets, or you can say that the corners. Okay, these are the holes. One by one we will discuss how these uh, parts are designed. Okay, how the design of the rib is done, how the bosses are designed, how the gusset is designed, how these radius and fillets are designed, how these holes are designed. Then in this design we are going to discuss the points related to their dimensions and their positioning or their location. Okay, now we will start with the ribs. Sorry. Sorry. So initially we will try to understand why it is necessary to provide a rib. Okay, now it is having, or you can say that rib is nothing but a long protrusion. Okay, protrusion which is provided on the plastic part. So long protrusion or long extension, you can say that, it will be termed as a rib. What is the purpose of providing a rib? A rib is provided to, for the decoration to provide some attractive look to that plastic part, or you can provide it to give some extra strength to the plastic part, and it is also it will prevent the warping of that component or that part. Okay, whenever extra load is there, it will try to bend, or there will be some distortion in that part. It will be termed as the warping of the component, and with the help of these ribs you can provide the sufficient strength and you can avoid the warping of the component. Okay, so I will repeat it. Ribs can be defined as long protrusion on the part, and why it is provided? It is provided for to decorate the part, to provide the strength, and to prevent the warping of that particular plastic part. Okay, so again in the next statement we have repeated this part. The function of the rib is to increase the strength and rigidity of the molded piece without increasing the wall thickness. Okay, what is the main point here they have added? Without increasing the thickness of the wall. Okay, without increasing the minimum wall thickness, we are going to provide, or we are going to increase the strength and rigidity of the plastic part. And to achieve this we have to provide ribs. Then these ribs provided will again it will help to increase the flow of the molten plastic material during the molding process. That is, the ribs facilitate smooth flow during the molding process. This is another function, or another use of these ribs. Okay, then now, while designing the rib in any plastic part, you have to take into consideration 5 points, or five main issues you have to take into consideration. That five issues or 5 points will be like this. First, you have to take into consideration the thickness. Means thickness. What thickness you are going to use for that particular rib? Then, what should be its height? After that, where it should be provided means its location. And then after deciding the location you have to decide the quantity. Okay, decide the quantity, and you have to decide the moldability. Okay, decide the moldability, or how it will provide the smooth flow. Okay, depending on these five factors or five issues, the design of the rib is done. Okay, these five factors you have to consider while designing any rib in the plastic part. First point you have to take into consideration is the thickness of that rib, then height of the rib, then its location, then its quantity, and how to improve the moldability with the help of this rib. Means whichever rib you are providing, it should be helpful to increase the smoothness of the flow of the during the molding process. Now we will move. Okay, now we will move towards the actual design considerations. Okay, now some design considerations are there that I will explain with the help of diagram. Wait for 1 minute, some disturbance is there. Wait. Okay, whichever points I have collected here in the design guidelines. Okay, ribs design guidelines, that I will explain with the help of a diagram. Okay. Okay, I will just go through it, and after that I will show you in the diagram. Okay, instead of here in this point will explain you, instead of providing a single rib, go for the number of ribs with minimum thickness possible. And while designing any kind of the rib, you have to take into consideration that rib thickness. Okay, rib thickness should not be more than whichever wall thickness you are using, it should not cross that value. Okay, then generally here it you can see here, or you can read clearly here, the whichever rib thickness you are going to decide, it should be 50 to 60 they have provided here. Sometimes you can go for up to 50 to 70 or 80% also. Okay, 50 to 70% of the wall thickness. Okay, whichever wall thickness you have used for designing that plastic part, you have to take the 50 to 70% of that wall thickness as a rib thickness. Okay, why we are going to do this? Because it will increase some defects like the sink marks. Okay, what are the sink marks? That I will show you here. Okay, if suppose this is the wall thickness. Okay, this is the first diagram. Here it is showing that the thickness of this rib, this is the rib and this is the wall thickness. Okay, this is the adjacent wall and the wall thickness is t. And if suppose you have designed a rib with the thickness equal to the design a rib having thickness same as that of wall thickness. Okay, here wall thickness is t and rib thickness is also t. Then what will happen? At the bottom side here, sink marks will appear. Sink marks will be formed. Okay, sink marks will be formed as you are designing the thick, you are using thick ribs. At this bottom side, sink marks will be there. Okay, so to avoid these sink marks, what you have to do, you have to use the wall thickness within a range, or it should be less than the wall thickness. Okay, whichever rib thickness you are providing, it should be less. It should be 50 to 70% of the wall thickness. For example, here I have taken this rib thickness 0.6 t. Okay, zero point 0.6 times the wall thickness. This is the wall thickness t, and this rib thickness we have taken here 0. 0.6 times the t. It should be less, and means generally we are taking 50% to 70% of the wall thickness as a rib thickness. Okay, to avoid the sink marks. It is very helpful to avoid the sink mark. Okay, and then the next consideration here, the rib height. This is related to the rib height. Okay, these 2 points I will directly take you to the diagram so that you will clearly understand. Okay, so I will try to explain all the points with the help of these diagrams, and that points you can go through the that slides for your reading purpose. If all the points can be explained with the help of this diagram. Okay, this is the diagram here, and this capital T will indicate the wall thickness, and these two ribs are provided here. Okay, now some design guidelines related to the height of this rib, whichever rib you are providing, its thickness should be here they have thickness should be within the range that is 50 to 70% of the wall thickness. Then its height should be three times the wall thickness. Okay, it should be three times h should be equal to, you can say that the 3t, this capital T, three times the wall thickness. Then distance between, suppose instead of using a one longer rib, you can go for number of ribs, two or more ribs, and spacing between two ribs, two consecutive ribs, it should be two times the wall thickness. Okay, this distance between two successive ribs, it should be yes, and this yes should be greater than two times the wall thickness. Two times wall thickness. Height should be three times wall thickness, and distance between two successive ribs, it should be two times wall thickness. Okay, then whichever rib you are providing, you should go for, or you should provide a draft or a taper. Okay, whichever rib, these two are ribs, don't if you are providing straight ribs, it will create some problem while you are ejecting it from the mold cavity. It will create some problem. Then for easy removal, of the molded parts, or you can say that for increasing the uh, or for providing the smoothness of the flow, it should be with the some taper. Okay, you have to provide some taper, and here one draft angle is provided. Okay, draft angle from, you can say that, half degree to 3 or 4 degrees draft angle is provided. This angle, this is the indicated by phi. Okay, don't provide the whichever, you can say that sides are there, or whichever rib you are providing, it should be taper in nature, and at the top side it should have a radius, and it should connect the wall with a fillet. Okay, it should connect the wall with a fillet. At bottom side it should connect the wall with a fillet. And this here, you can say that this is the corner radius, and it should be within the range, that is 0.25 times the thickness, 0.25 or zero point 0.5 times. Okay, or you can say that 25 to 50% of the wall thickness, its radius should be 25 to 50%. Okay, angle will be provided, draft or a taper will be provided from zero point 0.5 degree to 3 degree. Radius should be provided from 0.25 millimeter to, or you can say that 0.25 times thickness to zero point 0.5 times the thickness. In this way, these are the general dimensions. Okay, base thickness of that rib, then its height, then you can say this is corner or radius, then draft or taper, and distance between the successive ribs. These all points you have to write, and why you are providing that, why you are providing it. Okay, these all points you have to explain. So in this way, these are some design guidelines. I will explain it again. If you consider this cap, this is the wall thickness capital T, then the rib thickness should be 50 to 70% of this wall thickness. Then height of the rib should be 3 times the wall thickness, and distance between two successive ribs should be greater than 2 times the wall thickness. Okay, it should, greater may be allowed, but lesser value is not acceptable. Then related to the radius and taper, taper you have to provide. Okay, taper you have to provide here, and the taper should be in the range half degree to 3 degree. Okay, taper or draft angle. Then one radius or corner is provided where this rib joins the wall. You have to provide one radius, and this radius should be 25% or 50% of the wall thickness. Okay, in this way you have to design the ribs. Okay, all these points explained here. Okay, one point here, you can say that 1.1 to 1.5. Sometimes you can go for zero point 0.5 to 3 degree also, whichever taper is there. And that taper, why we are providing taper, ejection of the part from the mold, it becomes very easy. Okay, these all points I have explained. The radius at the base where the rib intersects with the nominal wall, or your wall radius, 25 to 50% of the wall thickness should be provided. Okay, why this radius is provided? To avoid the space concentration. This part will get repeated again in the radius and fillets. Okay, after this we will move toward the next slide. Okay, now these are some design consideration. Okay, you can either go for, while making the modification or providing the rib, either you can go for a single tall rib. Okay, single tall rib, or the better design will be, instead of providing a single tall rib, you can go for number of ribs, increasing the number of ribs. Instead of one thin long rib, you can go for two ribs. Okay, thin two ribs, by following the design guidelines. related to their height, their distance, in some taper. You have to provide, this is termed as the taper. Some taper should be provided. It will ace the ejection from the mold. Okay. And instead of these sharp corners are eliminated here, one fillet or this radius is provided here to eliminate the stresses. Okay. Whenever sharp corners are there, it will increase the stress. To eliminate that, we have to provide the radius or fillets. Okay. Means instead of providing the a thick single thick rib, you can go for either a thin longer rib, or you can go for number of ribs. Okay, number of ribs which are very thin in nature by following design guidelines. Means between two successive ribs, distance should be minimum two times the wall thickness, two times the wall thickness. Okay, so here, and also these are, this is the rib part. Okay, this is the rib, this is the boss. Okay, in this first diagram, okay, here you can see only boss is provided here, only boss at the corner. Then as boss is at the corner, what will happen, this side becomes more thick. As you compare, uniform wall thickness is not achieved here. Okay, uniform wall thickness is not achieved, so stress will be more in this case. So to eliminate the stress, to provide the strength and to ace the flow of that material, a rib is provided here. Okay, a rib is provided. Okay, whenever you are providing the rib at the corner, in this way you have to provide it by providing the fillet also. Okay, radius or fillet is provided, and this rib is given here. Okay, in this way you can do the design of the rib by following the provided design guidelines. After that, we will move toward the design of the boss. Why we are, what is the meaning of that boss, and why it is provided, and how it should be provided, means related to the its dimensions. Okay, so this is the boss. This diagram you can see here, this is the cylindrical hollow portion is the boss. This cylindrical hollow portion is boss, and this triangular supporting portion is termed as gusset. Okay, we'll try to search for more diagrams. Okay, this cylindrical hollow portion, this is the boss. And what is this? In short, you can say that boss is nothing but the one protruding stud is there. In books, they have used these words. So instead of using that difficult word, you can say that this is one arrangement. It will provide, or it will helpful for making the assembly of the two plastic parts. Okay, if suppose one plastic, you want to join one plastic part, then whichever screws are required. Okay, I think, you know, whenever you are using your mobile, the mobile body, if you have seen your mobile body, or suppose you have played, means any kind of electrical equipments are there, that switchboards and all this. uh, Whenever you are fitting that screw, okay, whenever you are fitting that screw, it will enter in that boss only. I have collected one diagram here. Whichever screw is there, it will enter in this circular portion. This is the boss. Okay, you can say this is the boss. Okay, this is the screw. Okay, it will help in doing the assembly, joining one part to the another part. Okay, this is the, this green portion, you can say that this is the boss. In this boss, with the help of this boss, the screw will enter in this boss, and you will, it will helpful for doing the assembly of different plastic parts. That will be termed as boss. Here, this, in this way, here that screw will be fitted in this cylindrical portion, and this is the boss. This center portion, this cylindrical portion is boss. Okay, now I have shown you the pictures. Now bosses are, you can say that this is the protruding stud, you can say that one extension, hollow extension provided, and it will assist you to do the assembly. Okay, for assembling of a plastic, one plastic part to the another plastic part, it will be termed as a boss. Okay, now this boss can be used for pressed in assembly, self tapped screw assembly, tapped for standard machine screw. Okay, just in short you can say that it will help you to assemble one plastic part to the another plastic part with help of some screw arrangement. Okay, now to design, while designing this boss, you have to take into consideration some points, means related to its dimension, its shape, and its location. And that you have to avoid certain things, and you have to follow some standards. Avoid bosses near an outside wall. Okay, bosses, location of the boss, it should not be very near to the outside wall. Due to that, particular section will become weak. Okay, whenever design of boss is done, it should not be present very near to the outside wall. It will, due to that, that section will become very weak in nature. Then avoid the sharp edges. At whenever sharp edges will be there, more stress concentration will be there, and it will result in some cracks. Okay, now whenever some edges are there in the boss, you have to give the radius of a minimum zero point 0.5 mm. Okay, instead of using sharp edges, give some radius or fillet there. Okay, now to design a square or a rectangular shaped boss. Okay, square or a rectangular shaped boss, you have to provide a radius at least of 0.4 millimeter, and whichever the, you can say that the attached member to that wall, it should not be over. Okay, whichever attached member is there to the wall, then thickness of that, it should not be more than 80% of the wall thickness. Okay, this is nothing but your rib, any attached member to the wall. This boss is attached to the wall with the help of a rib, and that rib thickness should not be more than 80%. Already we have discussed in the rib design, its thickness should be 50 to 70% of the wall thickness. Okay, now you can say this is the design of the boss. Okay, this is the gusset that I have added separate slide for it. Now, okay, why we are providing this, we are trying to give the minimum thickness. Okay, why we are going for minimum thickness here? Some defects, this is the void means some air bubble or some gap will be there. And sink, this is the some sink mark, material will get moved towards the opposite direction during solidification, and here shortage of material will be there, due to that sink marks are created. Whenever more thickness we are using, heavy sections we are using, some sink marks, some voids will be there. So to avoid this, we are going to provide the manufacture the part with minimum thickness. Okay, minimum thickness should be there. Due to this, these voids, sink marks will get eliminated. Yeah, now I have collected some points related to the design, means related to the height of that boss, then its diameter. Okay, its internal diameter, external diameter, you can say that. Then how to provide the radius or fillet where it intersects with the wall. Okay, now these are the dimensions, you can say that. Okay, whichever thickness here, this is the thickness. Okay, this is the thickness of the boss. Now thickness of the boss, it should be less than that, whichever wall you are using, it should be less than the wall thickness, and it should be less than that wall thickness, and you have to use some parameter, it should be minimum 60%. It should be less than 60% of the wall thickness. Okay, This is the thickness of the boss, and this thickness of the boss at the bottom side. Okay, on the bottom side, it should be less than or equal to 60% of the wall thickness. Okay, from both sides. From both sides. Okay, this is the thickness. Then this is the internal diameter. So this is the internal diameter, and external diameter should be 3 times the internal diameter. And height of the boss, height of this boss, it should be 5 times the wall thickness. Okay, 5 times the wall thickness. And the fillet or radius should be at least 25% of the wall thickness. Least at least 25%. It should be greater than that, but least value should be 25% of the wall thickness. Okay, these points you have to take into consideration while designing a boss. Now, in this designing of this boss, okay, uh, this is the design of a boss. I have already explained it. Okay, this is the outside diameter. This outside diameter should be 3 times the inside diameter. Okay, and this thickness should be, already I have shown here, 60%. This thickness should be 60% of this minimum wall thickness. Wall thickness. Okay, and its height should be 5 times the wall thickness. Now, sometimes whenever you are providing the boss, it should require the strengthening of that boss. Okay, for providing or increasing the strength of the boss, we are going to use the ribs or some gussets. Ribs or gussets are used. Okay, what is the difference between ribs and gusset? Just related to their shape and size. This is the difference. Their function is same. This is the gusset. It will provide the strength and rigidity. Rib will also provide strength and rigidity to the boss. This central hollow cylindrical portion is the boss, and this is the gusset. This side, this is the rib, and these ribs and gussets are used to increase the strength of the boss. Okay, to provide the strength, because whenever you are using these screws to assemble it, some load may be applied. This boss will be subjected to the loading condition, and to sustain during that loads, it requires some additional strength, and which is provided with the help of these gussets and ribs. Okay, now these are some points you have to take into consideration of some dimensions. Um, Whenever you are designing the boss near a wall, okay, near to the wall, this is the wall, and here you are providing the boss. Okay, and now whenever you are using the boss, it will be with the, this is the rib, and these two are the gussets. This one is the set, this is the rib, and this is the wall. Okay, boss near the wall, and whenever you are providing the boss away from the wall. Okay, I will show you the diagram. This is the boss designed away from the wall. Okay, from this side, and from this side, from all 4 sides, you have to provide a gusset or ribs. Ribs or gussets are provided. Generally, gussets are provided. Okay, in this way, whenever you are designing a boss away from the wall, from 4 sides, or from 4 side, gusset is provided to give the strength. Okay, and whenever you are providing that boss, the means near to the wall, then you have to provide ribs. Okay, ribs or gussets. Only 1 or 2 ribs or gussets will be used. Okay, like this, gussets or ribs, 2 or 3. Try to show some more diagrams. Okay, here you can see, this is the boss away from the wall. These are the boss near to the wall. Then from this side, a rib or gusset is provided. Very near. This gusset ribs are provided here. See these diagrams. These bosses are near to the wall. Okay, and gussets are ribs are provided. And when away from the wall, then from all sides, four sides, you have to provide the gusset to provide the strength. Okay. Okay, here you can see this diagram. On this side rib and these two sides gusset is provided, that is near to the wall. Near to the wall, near to the wall, here one rib and two gussets are provided. Okay, and remaining you have to follow the that design of the box related to its, depending on the wall thickness only, its thickness, its internal or inside diameter or outside diameter, its height and the dimension of the set and the ribs are decided depending on the wall thickness only. Okay, depending on the wall thickness only, we are providing the dimensions for that boss design. You have to follow these instructions while designing a boss near the wall. And whenever you are designing a boss away from the wall, then for the providing the strengthening of that boss from all four sides, you have to provide the gusset. Okay, gusset or a rib. Generally, gusset is used here. Okay, these gussets are used, and the thickness of this gusset will be generally 60% of the wall thickness. 60% of the wall thickness, and then the inside diameter, outside diameter, you have to provide by following that guidelines. Okay, here I have explained the inside diameter, outside diameter. Inside diameter is t, outside diameter should be three times that inside diameter. Height of this boss should be five times the wall thickness. Then radius or fillet should be provided minimum 25% of the wall thickness, and thickness of the boss is 60% of the wall thickness. Okay, by following these guidelines and guidelines related to the rib and gusset, these bosses near a wall and away from the wall are designed. Okay, in this way, and the design of a boss, whenever you are placing it away from the wall, then you have to take the help of the gussets to provide the necessary strength. Okay, and we will, these are some designs of the bosses in this, which is the most preferred design and which design should be avoided, that are explained here. Okay, isolated boss, you cannot use the boss isolated or separately. It will be having very less strength. Whenever you are practically joining the two plastic parts, it will get breaked or failed. To avoid this, you have to do the strengthening of this isolated boss with the help of either you can use the ribs or you can use gussets. Okay, in this way you can use the ribs to do the strengthening and to provide the strength and the rigidity, or you can go for the gussets. Okay, these types of gussets will be used. Then whenever you are placing this boss is away from the wall. Okay, this boss is away from the wall. And suppose you are using the boss very near to the wall, then you should not design in this way. It should be used in this, with the help of this design. Okay, this correct diagram. In this diagram, you have to use a rib. One rib should be provided at the corner to increase the strength of that boss. Okay, to increase the strength, to increase the flow of the molten plastic material during the molding process. these ribs and gussets are used. Okay, now we'll move towards the next part, that is the design. Okay, design of the gusset in the plastic parts. Okay, already we have discussed in this design of the boss that these gussets are nothing but, okay, you can say that these gussets are nothing but a supporting arrangement. They will just provide you the necessary strength. It will provide the necessary strength required for that boss, or it may be required for some ages. Okay, to provide the necessary strength. Okay, these are the gussets. Now, how to do the design of that gusset means what should be its dimension, what should be the distance between two successive gussets. It is explained here. Okay, this is the component wall with T thickness, and this is the reinforcing edge. An edge is joined to this wall. Now, if T is the wall thickness, T is the wall thickness, then whichever gusset you are using, its thickness should be 50% to 70% of the wall thickness. Whichever components wall thickness is there, and then while providing the gusset to increase the strength, then its thickness means this dimension A, it should be 50 to 70% of the wall thickness. Okay, then distance between two successive or consecutive uh, gussets, it should be at least two times the wall thickness, minimum 2t. If greater distance or larger distance is provided, it will be best. Okay, or it will be better, but minimum two times the wall thickness distance you have to provide between two gussets. Then length of that rib is the C. Okay, C is the length of the rib, A is the thickness of that gusset, B is the distance between that gusset, and C is the length of that gusset. And this length, it should be two times the wall thickness, two times the wall thickness again. Okay, these design guidelines you have to follow. Okay, these gussets are also known as, you can say that, the triangular ribs. Triangular ribs. Okay, its thickness should be 50 to 70% of the wall thickness. And then the distance between two successive gussets should be more than two times the wall thickness, and its length should be also more than two times wall thickness. These design guidelines you have to follow while designing any kind of gusset, and its ultimate aim is to increase the strength of the whichever ages arrangement is there, supporting age arrangement is there to provide the strength, or you can say that to provide the strength to the boss, strength and rigidity to the boss. And that boss is ultimately helping us to join different plastic parts. Okay, so in this way we have discussed this, the design of ribs, bosses, then gussets. After this we will move towards okay, so I will, this is the common diagram showing this is the boss, this is the rib, and this is the gusset. Okay, ribs and gussets are provided to increase the strength and rigidity. You can in short you can say that just increase the strength of that part, or to provide the support to the boss. And this are radius and fillets are there. And drafts, okay, it will take some time. And so we will move towards one small point is there, that is the design coring in the plastic parts. Okay, okay, this is the thick plastic part. Okay, this is the thick plastic part, and two holes are there. Then instead of designing this heavy or thick plastic part, we are going to use to we are going to provide uniform wall thickness. In this heavy section, we are going to provide the uniform wall thickness with the help of steel coring. Okay, the steel sections are provided here, and this will be our end product. This end product, instead of using or manufacturing this heavy sections, we are manufacturing the plastic part with a uniform wall thickness. Okay, uniform wall thickness is obtained here. Okay, and this is done by providing some coring, and generally this coring is used or provided with the help of some steel materials. In the mold itself, addition of steel is done to the mold for purpose of removing the plastic material in that area. Okay, this is our thick section, heavy or thick section. If you manufacture this heavy or thick section, some voids, some sink marks, or some warpage will be there. Okay, whichever final product is there, in that some voids will may be there, some warpage may be there, or some sink marks will be there. Means whichever product will be manufactured, it will be having number of defects. So to avoid these defects, okay, we are manufacturing a part with uniform wall thickness. And to achieve this uniform wall thickness, we are doing the addition of steel. Okay, addition of steel coring is done here. Addition of steel is done here into the mold to remove this extra material. This extra material is removed in this particular area. This is termed as the coring. Okay, this is termed as the coring, and this coring is necessary to create pockets or openings in the wall. Okay, this is useful to create pockets, openings, or to reduce the heavily walled section. Okay, this is very large thickness, and this we have reduced by providing the steel coring. Okay, extra material is removed by providing the steel coring in this mold, and a part is achieved with the uniform wall thickness. Throughout uniform wall thickness is obtained. This is termed as the coring. Okay, this is the diagram. This is the heavy section. It will end up with sink mark, voids, and warpage. To avoid this, this extra material is removed by addition of steel to the mold. Okay, this extra plastic material is removed from both sides. This extra plastic material is removed to give the uniform wall thickness. This will be termed as the coring. Now generally coring is done at a right angle. Okay, the direction of the opening of the mold. Okay, whenever coring is done at the right angle, sometimes to do this coring, some cams or hydraulic mechanism you have to use. Okay, then sometimes you have to go for movable and loose piece cores, which may be expensive in nature. Okay, whenever internal undercuts or threaded molding is there, then you can go for this movable or loose piece cores. Okay, on the remaining points already I have explained, that is coring refers to elimination of the plastic material from the thick section. Otherwise, some defects may be created. Okay, these long cooling times, uneven shrinkage. This uneven shrinkage only leads to the that sink marks, voids. Okay, and stresses will be there. To avoid this, this coring is done, and this coring is done in this way. Some diagrams are there. Okay, this is these are the incorrect designs or initial designs, and these are the final design after providing the coring. Okay, this thick section. Okay, thick and non-uniform wall sections are there. These are converted into uniform wall section. Okay, parts having uniform wall thickness, and here extra material is removed by providing the steel into the mold. Okay, uniform wall thickness is achieved. Here also, instead of making this thick section, this uniform wall thickness is provided, and this extra steel material will be provided. Okay, this shape also, this is the thick section, here also and here also thick portion is there. It is converted into uniform wall thickness throughout in this way. And this extra material, okay, from this side extra material is removed by providing the coring. These are incorrect designs or initial designs, and these are modified or correct designs by providing the coring to get the uniform wall thickness. Okay, so if you are having any query, you can put that in the chat box. So in this way, we have completed in this session design of the rib. What is the purpose of providing the rib? Okay, what is the purpose of providing the rib? To decorate the part, to provide the strength, to avoid the warpage, and how it should be provided. Okay, means related to the dimensions, its thickness, its height, distance between two successive ribs, and what should be the taper or draft angle, what should be the radius. Related to this we have discussed. Then after that we have discussed the design of the boss. Okay, one protruding stud or one extension is there, hollow cylindrical extension, which help us to assemble two plastic parts, and how it should be designed, and why the ribs and the sets are provided here while designing the boss. What should be the dimensions, inside diameter, outside diameter, its thickness, its height, what should be the radius in case of boss. Okay, then how to design a boss near the wall surface and away from the wall surface. Okay, then it's correct design of the boss with ribs and gussets. Then design of the gussets are designed to provide the strength, or it is nothing but a supporting arrangement for the edges, and how its thickness should be 50 to 70% of wall thickness. Its length should be two times wall thickness, and distance between successive gussets should be two times of the wall thickness. Okay. After this, we have discussed this design of coring. Why is coring? These heavy sections are cored. Heavy sections are cored to give the uniform wall thickness. In these heavy sections, sink marks will be there. Sink marks, voids, stresses will be there. To eliminate that and to give the uniform wall thickness, steel material is introduced to remove the extra plastic material, and uniform wall thickness is achieved. This is termed as the coring. Okay, this is the coring. So in this way, in this today's session, we have discussed how the rib is designed in the plastic part, how the bosses are designed in the plastic parts, how the gussets are designed, and how the coring is done in the plastic part. Okay, all these parts we have discussed with their purpose, why we are providing them, and what should be their dimensions and where they should be located. Okay, so in this way we have completed this. In next session we will discuss related to the radius, then tapers or drafts, and some inserts, holes, that we will complete in the next session. Okay, so today's session is over here. You can, those who have joined, can put your attendance in the chat box. Okay, I will stop here. Thank you for attending this session. Okay, in next section, I will cover that design of that few parts, remaining parts, and I will take the numerical also. Okay, so please attend it. Very important part, that numerical one practical is there. Okay, I will cover it here only. Please attend that session. Thank you for attending this session. I will stop.